All right, guys, let's start our lecture. Okay. The next slide I'm going to talk about is another problem. Draw this diagram. You don't have to draw the full car. You can just draw a block of mass going on an inclined surface. Like this block, you see this block? Okay. Now a 2000 kilogram sports car. That's a sports car. And it is 2 tons. Oh, wait. A car increases its speed uniformly from rest. Initial speed is 0 and final speed is 25. Oh, sorry. Yes, it is 25 meters per second. And in the time duration, it is 30 seconds. That's interesting. Do you know what is, how can you find the acceleration if the final initial speed is given? You remember the formula for finding the acceleration? Acceleration is equal to change in velocity in the duration. You see that acceleration formula? So what is that equals to? Because you need it. 25 divided by 30. How much is that? Is it 0.8 something? 0.83. That's good. So that's good. We have found another variable, meters per second square. Acceleration is always important. So keep an eye, like efficiency is given. When efficiency is provided, means we have to either find out initial power or input power to the engine. So it is asking you find the maximum power and the average power supplied by the engine. So engine supply, the supplied power, I was probably, I would take my words back. The engine power, it is output power of the engine. Suppose this is the very rough diagram of the crankshaft, the ring piston, inlet manifold. So this is the CV axle and this is the wheel. So this is the wheel which is going on the flat surface. So there is certain components here. So power supplied by the engine, it is not inside the cylinder. So that was you can find out that efficiency of the engine in its sole device. But here the power supplied by the engine is coming out of the crankshaft. You see my point? And then that crankshaft is linked with the power transmission system. Okay, then that is linked with the wheels of the car. So this is the force and this is the velocity. Okay, now let's do this math here. Draw the free body diagram. Draw the car free body. Okay, let's draw the free body diagram and find out the maximum power. Now, in order to find the maximum and the average power, you know the formula is same, but you have to do one thing. What do you have to do? For the maximum power, the force is same, velocity is maximum. Average power, force is same, velocity is average. So when the velocity is maximum, what is the maximum velocity, which is 25? And what is the average velocity? 0 plus 25 divided by 2. So first thing is find out the force. The driving force, which is the required force to move the car up on the slope with that velocity. Okay, this car is going up on a slope. And if I draw the free body diagram, this is W and this is the force. I have to resolve this into two components, and this is theta. Can you find out theta if the slope is 110? Theta equals to opposite over adjacent, tangent inverse. Opposite over adjacent. Okay, what do you guys get? 5.71. One student says 5.71 degrees. So theta is given. So let me show you. Let me show you over here that the free body diagram. Let's draw the free body diagram here. We already drawn the free body diagram. Let me show you the final. If I draw the Newton's, if I complete the Newton's second law. So this is the car, okay? The weight is downward, and this component is responsible, and the force, driving force is in the direction of the velocity. Agreed? The driving force is in the direction of the velocity. The velocity is also upward direction. So this is theta, which is given. So I can write down here F minus W sine theta m times acceleration. Acceleration you already found, 0.833. Can you find out the driving force? W 2000 times 2009 times 9.8 sine 5.7 degrees plus 2000 times 0.833. Can you do the math? The force comes in my notes. The force, it is 3,619 newtons required to drive the car uphill. This much force. Do you agree with your professor? Do you agree with your professor? Now we have found the force, and the power is force times velocity. Velocity is already given. Maximum is 25, average is 12.5. Just multiply these two numbers to find out the answer. That's it. So let's do the math here. So maximum power equals to, this is power maximum equals to, this is output power. By the way, this is the output power because the force is the traction force between the tire and the road is output force. So force maximum, force remains same times the velocity is maximum. 3619 times 25. What do you guys get? This is 90.47 kilowatts. Agreed? And if you find the maximum power output, this is the output, okay? What is the input power maximum? 90.47 divided by, what is the efficiency of this car? Engine, this is 0.8 divided by 0.8. It is 113 kilowatts according to my notes. And the average power, let's find out the maximum output, sorry, not the maximum, but the average power. As I mentioned, the formula will change. Just the change the velocity from velocity maximum to velocity average. The force will remain same, 12.5. If you do, this is the output power, 45.28. And the power supplied by the engine, divided by input power, average equals to 45.28 divided by 0.8. If you solve for this, you should get 56.5 kilowatts. Can you solve such a problem in your homework or quiz or test? Or will you do mistake? There is a quiz next week, so please practice all those problems which I assigned to you in an email at this students. Did I assign you? I don't know. On the D12, I'll make sure you can remind me if I did not. I'll upload homeworks for 14th chapter. All the homeworks are included for the chapter 14. Is it due today? Yeah. Do you want me to extend the deadline for? Yeah, maybe at least Thursday. At least Thursday. Okay, I can do that Thursday. We will do it after the class. We will do it. Okay. He is my helper.
Do you want us to use the same ones that help us?
Yes.
Okay.
Those are the same problem. Yeah. We will do it after the class. Okay. Excellent. Because if I go away, I can forget. Some other work suddenly comes. So he keeps reminding me. Have you guys understood this problem? Okay, the quiz question. Are you ready for the quiz question? First quiz question, please answer. One student says power supplied by the machine, which is the output power, is always dash the power supply to the machine. What should I write here? You guys are smart. That's good. How about the next quiz question? You did that in a blink of an eye. You guys have good concepts about dynamics. One student says it is C. Any other student? Another student says, yep. So it is C. Because we have to find out the power, find the combined friction force on the tires, and that is equal to force times, sorry, for we know that the force times loss of power and the force of traction force or is also is confusing. Let me show you the combined friction force and the traction force and the driving force. They are the same things. So P over V. Because in a car, you see, if the car is here and you have you are on a road, and that the force is actually the driving force is actually in the reaction of the friction force between the tire treads and the road. If there is no friction, they will start slipping, which is like coefficient of friction involved. Here there is no coefficient of friction, but it is known as the friction required to drive the car in a reaction force, which is equal to the friction between the tread, car tires, and the road. That's why the greater the tread on the tires, better the grip on the road and better the force, driving force. So we have finished this section, but you see what is it written? Let the learning. So I will emphasize this word, continue. And even at the end of the semester, I'm still learning. Even at my age, you will still learning. So you will even graduate, you will go to industry, you will still keep learning. And it's good to learn. We still have about 15 minutes, right? Oh no, time passes fast. I try to be a little bit fast today, but I have to explain the material. Or should I leave it to you guys to? I'm just joking. Students need to learn in the class. Okay, you see, I talked about the conservation of energy principle. We did not solve any problem regarding that in the previous section. This section is all about kinetic energy, potential energy, strain energy, equality of. So let us do that problem. Are you ready? Or are you tired? Let learning continue. What do you think for first quiz question? What is the answer? Always positive. Why is that so? The strain energy possessed in the stored in the energy, which is a potential energy, the we call Vs half K delta S or delta X square. Even if the spring is compressed or stretched, so from the normal, this is a normal position. Okay, normal position. So even if it is compressed, you get a negative number, suppose negative number or positive number. What are the square? Square of a negative number is positive. The energy stored in the spring during the compression state or stress state is always the same. Positive energy, correct? What is the potential energy of a conservative system? When the potential energy of a conservative system increases, what happened to the kinetic energy? Always decreases. And conservative system is a system where we don't have any friction losses. We assume although air is present, if there is a swing in the air is still present as friction, but we neglect it for our simplification. I'm going to take this figure and put it over here to explain everything which I did over here one more time. Okay, kinetic energy formula, potential energy formula due to the gravity, potential energy stored in the spring, half kx delta x squared, and the pendulum is moving in air, and we actually at each instance the sum of the two energy is always constant. That's what sum of the you will in this chapter you will see that the 2 points will be 2 positions will be considered, and you have to compare the kinetic energy, potential energy, strain energy between those 2 positions to find out the unknowns. Suppose final velocity is asked, you will do the same procedure to find out final velocity. So let's do the math. We still have about 10 minutes. And I skipped one slide. So this is the application. For example, this is a chair which has springs and just like it is a weight, like a sack of maybe whatever weight of this sack is, you have put it on the chair which has springs. So springs will be deflected. Once the springs are deflected, so you will find out the strain energy stored into the springs from this formula. So Vs equals to half and if you release it by some trigger mechanism, if you just release this chair, that will convert to the velocity. So this chair will certainly jump upward if you release the stored energy in the springs by certain trigger mechanism, and this sack will move at a certain velocity, which you can find out from this conservation of energy principle. You understood this logic? So you can apply this kind of concept to find out the final velocity. This guy is pulling this some machine. It has springs, and you see these are 4 springs. 1, 2. This is 1, 2 rubbers. These rubbers are actually like spring, and this is like a catapult. You are just pulling that and just throwing the ball inside to hit the target. So you can find out the same. All the stored energy in the springs, they are equal to half mv squared. So you can find out the final velocity of the, which is actually the starting velocity of the ball, projectile velocity. You see my point? So another application is very interesting. Have you taken a ride on a roller coaster car? Yes? You see, the roller coaster car starts from the highest position, and position A is the highest point, H. And then position B, next highest, position C, third highest point. So then it travels outside on the ground. You can, yes. Tension is a high because the datum line is the bottom. We have assumed this is the datum line, okay?
Can't have like one, so once the highest point is established, you can't have something higher than the lowest.
No. You should go down and down because the energy is converting into the kinetic energy. And suppose if the loop is smaller height here, then you still have sometimes the high velocity can also detract the car outside. If the highest point, you should design the next highest point such that you should have a minimum velocity when it reaches the top position of point B. Otherwise, it may sometimes there are certain safety mechanism required. What should be the velocity such that you should not even lose the track. Okay, and people want to go to the highest point, you see, so they don't want to keep very low at the point B, but they don't want to keep so high so that if we lose and they will detrack and will come down. You see my point? Sometimes if your height B is higher than the required energy, because it requires energy to keep the car on the track, so you will fall down at point position B. There might be some accident in the past you might notice. Have you noticed some roller coaster accidents in the past? Oh wow. Hit somebody. That's not good.